Hello. This video is a part of two different, this is part one of a two-part video over law of sines. This is part one, solving for a side. And this is just an extension of some trig stuff. This is not with right triangles. So this is a law that was come up with, and if we were in class we would sit down and we would prove this law, but we're not in class, so I'm just kind of cutting straight to the chase. This is a law that has been adopted to be able to solve for sides and angles of triangles that aren't right triangles. The law of sines is, I'll just read it from the notes we would have taken, and well, I'll show it to you. These are the notes we would have had in class, but we'll just do it on a piece of paper. You don't have to copy this down if you like this sentence if you don't want to, but for any triangle ABC, so this is for any triangle, not just a right triangle, let the lengths of the sides opposite angle A, B, and C be A, B, and C respectively. So the side opposite of angle A, we are going to label lowercase a. The side opposite angle B, we're gonna label lowercase b, and the side opposite angle C, we'll label it angle C. Side C. Then the law of sines relate the sine of each angle to the length of the opposite side. Okay, so we have the ratio of the sine A over side A is equal to the ratio of sine B over the side across from it is equal to the ratio of sine C over the side opposite of sine C. It's kind of confusing, but it'll be good. Okay, so anyways, we have any triangle with angles A, B, C. We're going to label the sides opposite those angles just lowercase versions of themselves. So A, B, and C. Okay, so here's the law of sines. Sine of angle A over the side opposite is equal to sine of angle B over the side opposite is equal to sine of angle C over the side opposite. So we have three ratios here that we're going to use to set up proportions and solve for unknown variables. So let's just start with example 1. I have some triangle A, B, C, and it is given that angle A is 60 degrees, angle B is 53 degrees, and angle C is, we don't know angle C. Well, we could solve for angle C, but we don't need to know it. And we are looking for BC, we have BC, which is 24. And the question says, what is AC? Question mark. So let's label AC. AC, side AC is across from angle B. So let's label it B. I'm also given one other side. I'm given this side. What angle is this side across from? A. Okay, so let's set up a ratio. Now we won't need all three of these ratios. We'll only need two of them to set up a proportion and solve the proportion. So we have sine of angle, let's say 60, over the side opposite, 24. Okay, so again, I take the sine of one of my angles over the side opposite that angle is going to equal sine of 53 over my unknown B. And we're going to cross multiply and divide and solve for B. Okay, so I'm going to multiply these two. And I'm going to multiply these two. And I will divide by this one, by sine of 60. So again, your cross multiply, divide. Okay? So B will be whatever this right here is. 24 times sine of 53 divided by sine 60. So again, I did 24 times sine of 53 divided by sine of 60 is 22.1. And that would be the answer. Okay, so let's do a couple more because that was just the first one, so that might be a little tricky since it's new. Okay, so I have a triangle, example 2. We're just doing 3 examples. I have a triangle. I'm given this angle. I'm given this angle. I'm given this side, and I'm looking for this side. Okay, so you can come in and label your angles and then label your sides. So the side opposite angle A, we're going to label it A. The side opposite angle B, we're going to label angle B. And so what we're using is we're using this proportion right here. So sine of angle A over the side opposite angle A equals the sine of angle B over the side opposite of that angle. And then we are cross multiplying and dividing. So x will be equal to 17 times sine of 56, cross multiply, divide. So we are going to do 17 times sine of 56 divided by sine of 77. So the side is equal to 14.46. We're going to round to the nearest tenth. So that it would round up to 0.5. So again, we cross multiply and divide. Here we cross multiplied these two and divided by that one. I hope that you guys over at 3 Lakes, that's kind of how I do proportions really quickly. I hope that makes sense. Let me know if that doesn't. But you cross multiply the two parts of the ratio that you know and divide by the one you like is across from the one you don't know. I hope that makes sense. I don't know how y'all teach it over there, but okay, last example. We have this obtuse triangle. I have 2 angles. I know a side, and I'm looking for another side. So if you know 2 angles, you know one side, and you're looking for the other side, and it's not a right triangle, you're going to use law of sines. So let's do sine of 135 over the side opposite is equal to sine of one of my angles over the side opposite. Okay, I cross multiply these two. So I will have 14 times sine of 135, and then I'm going to divide by that one. And that is what x will equal. So (14) times sine of 135 divided by sine of 24 is 24.3. And that is how you find the side of a triangle that's not a right triangle using the law of sines.